Welcome to The Index. I'm your host, Alex Kahaya, and today I'm excited to have Vincent, who is the co-founder and CEO of Prime Intellect. Prime Intellect is on a mission to democratize AI development at scale, making it easier for anyone to find, compute, train powerful models, and co-own the results. Their platform connects global compute resources with distributed training infrastructure so that developers and researchers can build and share open AI innovations from language models to scientific breakthroughs. Vincent, thanks so much for being here. Really excited to learn more about what you guys are doing.
Thanks for having me and excited to chat.
Yeah, so there's so much in that about what you guys do. You guys have really bitten off a lot as a company. There's like a lot of problems you got to solve in order to make that mission come true. So I want to break that down a little bit. But before we do, I'd really love to understand why you get up out of bed every morning to work on this. Like, what's your story and what's driven you to try to work on such a hard problem?
Yeah, great question. So I think really for me, like it started out in my early teens, basically just like getting excited by technology and startups and by computers largely. And then like basically starting to build like stuff in the internet in my early teens, but then really quickly coming across some of those like well-known figures and builders and being like inspired to ask myself like the question really of like, still in school, my early teens, like what do I want to work on like for my life? Like what are the basically most exciting technologies that like, drive like humanity's future? So actually like prompted by Elon, like I think over 10 years ago, like dropping this like as a like questionnaire ponder to like do his efforts, I asked myself the same question and kind of like really just like explored like quite broadly different areas actually like more than like I think like 12 years ago or so, dived in quite deeply in like AI, bio, and everything else from like space, energy, nanotech, and whatever else. And ultimately, like at the time, like the book Super Intelligence came out by Bostrom like 2014. So I read that book and I think that really like planted a seed alongside like Ray Kurzweil's book of like the singularity for basically just like potentially exponential progress, like human progress, scientific progress, coming from this idea of like advanced AI progress. So basically really kind of like since then, like I was really like captured by the idea that like AI is probably the most consequential technology for humanity. But at the same time, like I also explored quite broadly like areas of science, like for example longevity, but also like got really excited by some of the like possibilities around crypto. Like I was aware of like Bitcoin since kind of like 2012, but like it didn't really click for me. But like what started clicking was like when I read basically I think 15 or so like the Ethereum white paper and kind of like this idea of like the DAO that like basically anyone could like fund like science, could fund like technology. Seemed quite powerful. So I just basically like naturally like explored all the different areas, but like ultimately like AI was the thing that like for me was obviously kind of like the most impactful and most consequential, but it also was quite relevant to make it open, to make it decentralized and not necessarily in a very traditional frame like very traditional like B2B SaaS startup or something, but rather exploring if there's novel ways to advance it, that are kind of like on a unique like path to actually help humanity.
Oh, sorry, I didn't realize I was on mute still. So I was going to ask you, one of the things we read out here in the intro here is the democratization of AI at scale. And I kind of wanted to break down for a minute what that actually means. What does that mean, the democratization of AI? What does that look like? And how is that different from today?
Yep. Yeah, I think like it's an overloaded term. So I think another way for me to phrase it is to an extent almost like commoditizing intelligence and compute. I think is like extremely important. And I think like ultimately the main force of this actually I think are markets. Like markets have like really delivered us like a lot of goods, right? At like at the cost of capital, basically at the cost of their production, right? It's like from mobility to like now intelligence and like everything else, right? And I think really like what we realize is like there's two things that I think quite important. It's like ultimately like the cost of using an AI model, right? Like the cost of using intelligence is like downstream of like the cost of compute and energy. So really, I think what it comes down to is really figuring out like how to drive down the cost, but also at the same time, how to build like a model that actually is aligned with the user and isn't basically adversarial against the user, right? Like not like kind of like the traditional, almost like ads-based business models where almost like the user becomes a product, right? It's like, but rather where ultimately just like we get to like intelligence and compute too cheap to meter, basically. That I think that's the ultimate path to make it like widely accessible and democratized, is really to facilitate the most efficient market for computer intelligence. But I think there's another layer to it where it's actually the research that enables this. Like basically, like distributed training is one example, right? It's like if you have like computed like the different costs around the world, you can only leverage like the cheapest compute that is like only potentially available for a short burst of time if you have distributed training. So like distributed training unlocks you to basically make more efficient use of like idle compute around the world, right? It's like, and that then ultimately drives down the cost of compute and the cost of intelligence. And similarly, obviously with open source models, like we've seen with DeepSeek, for example, right? It's like really like those open models, right? It's like just create like an explosion of like open source innovations of like serving the model cheaply, building like the most exciting like use cases on top of the model. And I think it ultimately generates like the most, just like public goods, basically most value for humanity, right? Like it doesn't necessarily all get captured by one single entity or company, but like I think that's kind of the point. It's like they were almost like ushering in this like more like abundant future, hopefully. And I think the path to get there really is like to commoditize like everything, but like for us, the focus being on computer intelligence as the kind of like the core drivers.
Yeah, I think one thing I would add to that, just in my opinion, is that open source really matters, and that you need this kind of market in order to support the open source development,
Yes.
like to create the economy around it, because otherwise you get this centralized capitalistic endeavor. And I believe in capitalism, but I like open permissionless capitalism versus centralized permissioned capitalism. And the real danger there is that you get super intelligence in the hands of a few people and countries, and instead of democratized super intelligence, right? Where anybody with the will to do it can just access this stuff, spin it up on their own, contribute to it, modify it, leverage it, and it's never going to be restricted from them. And I think totally, like there's all these people that are like worried about that future too, because it sounds kind of crazy. But the alternative is that is sort of, I mean, I think it's un-American, honestly. Like if you look at like American ideals for freedom, for example, the alternative is Orwellian. And that's not a future I want to see. And that's why when I reached out to you to come on the show, I was excited about what you guys are doing. So I don't know if you have any thoughts on that, but that was just my dovetail to what you just said.
Yeah, like perfectly said. Like I fully agree. Like I think really like it's quite important, and basically I think the natural forces are what we see play out, right? It's like with companies trying to capture the value for themselves, trying to like limit it to, and close it down. And I think really like one needs like a strong counter push to that, because I think it's not inevitable that we'll like automatically like get this like freedom and like open and decentralized future, right? Like for AI. I think there's like a lot of forces pushing against that, and like strong incentives pushing against that.
Yep. So let's break it down a little bit. So can you tell me a little bit about the core innovations of Prime Intellect and like the problems that they solve from a technical perspective? Like how do you enable some of these things, and what are they?
Yeah, I think there's like different layers to it. Like I think at like maybe like almost chronologically of like how we started, I think one layer how we started really is like building up like integrations to all the different hyperscalers and data centers in the world. And I think that's actually quite relevant and requires like a bunch of like orchestration to actually like basically orchestrated kind of like global fabric of like compute, right? I think there was like layer one that I think is like sometimes overlooked, and like a lot of like efforts haven't done this yet, but it's like really connecting to all the different data centers, also figuring out like what are all the different like challenges with each, right? It's like not every GPU or not every data center is the same. So kind of like successfully building the engineering stack around that. But I think more so on the research side, right? It's like then we did the first like large scale distributed training run, right? Like a 10B, like over a year ago now. Like at the time, like 1B I think was like the highest that had been achieved. Like we moved it up to 10B with like this basically distributed low communication training called Dialoco, which was like a research project within DeepMind that they published, but they only had they hadn't fully open sourced it, and they hadn't fully scaled it in the open. So basically, we took that research, we improved upon it and advanced it, basically on like 2 or 3 different axes. Like on the one side, like we made it more fault tolerant. So if like one GPU fails, right, like that, not the whole training run fails. We added like a bunch of like other ways basically to shard like the models efficiently to basically scale to that model size, right? It's like natively, I think it wouldn't have been possible to scale to the 10B model size. And then we basically open sourced the whole framework and also every piece of the stack, right? It's like data, the weights, the models. It's like basically proper open source, not just like giving you like a model weights at the end of the day, but like actually the training code, right? It's like the data that went into it, the algorithms. So I think really there, like we again like learned a lot of just like scaling those real world systems, right? It's like we trained this model intercontinentally, like between like the US and Asia and Europe. And a lot of it comes down into like efficiently communicating across this mesh, right? Like between different data centers, and once you move, like it's actually much faster to, for example, train a model distributed, right, like across like one continent like the US, because like ultimately the internet connections within the US is faster than like say to Asia to Europe. But like that was step one, and then really what we kicked off actually this week was basically scaling this much further, and I can also go into detail and a bunch of other things we did on in the meantime. It's like to really scale this into this new basically inference time compute scaling paradigm, right? Like with distributed reinforcement learning. So basically, and DeepSeek obviously famously kicked this off for the open source world. Obviously O1 from OpenAI was kind of like the first like closed example of it. And I think really what's powerful is that actually it's a scaling paradigm that is like extremely well aligned with like a distributed setting, because you actually have like less communication requirements. So what we actually now did, which like involved like a lot of different pieces, is on the one side enable trustless compute contributions. So anyone can join with their own, like spin up basically a miner on their H100, for example, and join that compute. So we did this thing called Toplock, which is like an extremely efficient and low overhead like mechanism for verification of the compute. And then on the other side, we basically build a distributed reinforcement learning framework, like an efficient like communication library to like communicate those different workloads across the globe. And and also in the process basically develop like the most efficient mechanisms to generate like synthetic data, which is like a core ingredient of scaling, kind of like in this new scaling paradigm, with basically loops where ultimately like the reinforcement learning has like a verifier, right? For example, for code or for math, to generate verified data, like basically to get rewarded if, for example, the code or the math, the model outputs is correct or if it's wrong, right? And in that way, basically self-improve with like reinforcement learning. So that's another core piece that we built. But I think really zooming out, like we're basically trying to put the different pieces into place for like open and decentralized superintelligence, like what's necessary to basically, from a technical perspective, get there. And what's also like, which pieces do we need to prioritize to make sure, we are basically putting like the foundations in place.
Dude, we should work together to make like an infographic of what those pieces are with some like explainers, because I have been, I told you before the show about the open intelligence thesis I've been working on. That has really kind of been developed from my work with Bagel Network. Bidon they're a sponsor of the show, and we have like a sub segment called Everything Bagel where we talk about like AI stuff with them, and yeah, that idea of open source AGI or ASI on crypto rails was really born out of a lot of conversations that I had, and you guys separately had that very similar language or almost identical language. Like when I read your announcement about your funding, I was like, oh yeah, these guys get it. Like they totally get it. And I've been thinking about it like a factory system, and I'm not an engineer, so I don't know, there's different components and different mechanisms and different inputs and outputs at each step. But there are these components. They all need to be open source. Some of them are going to run on actually like use blockchain technology probably. Some of them might not, but at the end of it, there's like useful apps and stuff that people can use that take advantage of this tech, that take advantage of AGI. And I think that's the future. And I think that the economic models around these tokenized projects are the thing that accelerate us to that. They create this cycle of people contributing that then will accelerate its development. And I think honestly, I want to use open intelligence as like the drumbeat that every founder that's working in this space starts beating in public to like push all the engineers that are out there, all the people who could contribute to this mission to contribute. It's like the thing we need to beat that drum like super hard and super loud, because if we don't, then ASI is going to get shipped by somebody else in a centralized manner before, and that might be a problem. Like, it's kind of hard to fathom how powerful the technology is going to be and the implications of it once like a few people have access to it. And I feel like it's almost like a nuclear arms race. And I feel like I hate to be like dramatic about it, but that is kind of how it feels. And so for me, it's not about making money or anything like that. It's purely like altruistically about humanity needs fair democratized access to this tool. And if it doesn't, then I don't want to see what that reality could look like, Yep.
Like I fully agree. I think there's basically like different paths to get us there. But I think like to your point, like I think like obviously like famously the OpenAIs of the world tried to get there as well, right? And I think ironically now it's more like players like DeepSeek that are basically carrying the torch, which I think is like, in many ways, to your earlier point, I think it's actually quite important to have a basically frontier like open and decentralized like AGI lab that is actually like has more like the values of like freedom and democracy in mind, right? And like fully aligns with that. And I think the other piece which you also mentioned is like really figuring out like the model that actually has a chance to compete against like the incumbents. And I think really, if one just looks at like historic GPU consumption, right? Like the only one who got close to like the hyperscalers, like basically the frontier AGI labs, is actually the largest like blockchain networks, right? It's like Bitcoin and Ethereum basically, like ultimately consume more GPU power or more flops, right? Like than most AGI labs. But I think in that sense, like it's actually quite promising to like explore the intersection. But I think there's also obviously like some challenges that remain. I think really at the core of it, I think it's really about figuring out like which pieces like basically get the most like accelerated and like towards that open and decentralized future, like by also like coupling it with crypto.
Yeah. So I want to hone in on a little bit on something you said earlier about the pathways between data centers and the data transfer. So this is a huge problem in really just generally speaking on the internet, is like getting bits from one place to another efficiently. But especially in AI training, like there's a reason why Elon Musk built like a massive, 100 gigawatt,
200,000 H100s by now.
Right. In one data center, right? And those things are networked together, wired together. And that's because the distance between those machines and the data passing through them is as short as possible. And so it's a very cost efficient, hyperscaled way to train an AI. And so doing it in a distributed fashion across a lot of data centers requires this really efficient pathway to get data to and from these nodes on the network. Yep. And I wonder, what struck me is that the problem you guys are solving there is very similar to what 00 is doing in their N1 thesis. And so I'm curious, like, have you looked at double zero and how that works, and how similar is that to what you're doing, or does it complement what you're doing? Like, do you think it could work with your system? I'm just curious about that.
Yeah, like actually, yeah, we've come across them. I think in many ways, almost like zooming back to I think the actual challenge is, I think, like basically how models have been traditionally trained in a pre-training paradigm, which was the paradigm till last year maybe, like, but not anymore necessarily. I think that basically required highly synchronized training that basically communicated every training step, which could be like once a minute, for example, like, right, like very frequently. And now I think, like in our paradigm, we only communicate every 100 training steps, which is much less frequent, so more like once an hour. And really that like unlocked us to communicate like over the internet at slower speeds, instead of communicating at these like very high speeds locally within one like centralized location. And I think the interesting thing is like it's almost like two or three different things. It's like on the one side that even with what we did with this distributed low communication training, we kind of like started solving this for the pre-training paradigm. But we moved away from that paradigm, right? Like as an industry, into this more like post-training distributed reinforcement learning paradigm, which is very perfectly set up actually for like lower like synchronization. So it's like we actually proved this like 2 days ago in our release with like Intellect 2, that basically communicating less frequently, also in a distributed like reinforcement learning setting, yields a similar result as communicating extremely frequently. So basically we're proving the same thing also for this kind of like new scaling paradigm. But I think the other piece is that ultimately there are obviously different ways to also, like, we don't want to communicate at no speed over the internet, right? Like that, like you still need some speed, right? That's like in a sense, I think there's basically obviously a general trend with like undersea like cables between continents and like Starlink, all of these things like accelerate like the pace of like global communications, right? It's like it increases the up and download speeds we have over the internet. And then I think there's basically different optimizations that we are exploring, right? It's like to increase that speed. But ultimately, we're then basically moving away from like the actual fiber, like, or the actual interconnect in one data center to actually the interconnect between different data centers, between different countries or continents. But it starts to then become less relevant. And in a sense, like, because we're still training when it's communicating. So in this first approach, we basically did like a ring where and there was like a similar actually paper then later by DeepMind called Streaming Diloco, where basically you can overlap training with communication. So where basically you don't have to stop training while all the different workers communicate. You could basically, most of them could continue training and then they could communicate step by step. So there's basically different optimizations that we're playing with to like reduce that barrier. So I don't think it will be actually the main friction. I think at the end of the day, it's really about just like using the compute extremely efficiently, right? It's like obviously famously like a DeepSeek got with like much less compute, much further than some of the centralized labs, right? And I think that's the power of like open source and decentralized like AI, right? It's that ultimately like anyone in the world can contribute to it and is currently already contributing to the frontier of open source, right? And I think that really reduces the cost. But then I think really it's like if you have like an efficient recipe to like scale intelligence, which I think this current like inference time compute paradigm allows for, then I think we can basically much more cheaply like scale reasoning, scale like intelligence than was possible before. So I think that's the other like huge advantage beyond like communication. So I think communication is not the ultimate bottleneck. It's almost more like capital formation in some ways to get to the hundreds of millions or like billions to basically compete at the scale of like the closed source, like centralized labs.
So it's capital formation to get the compute.
Yep, exactly. It's like ultimately, I think energy, compute, capital, like they're kind of like you can exchange them, right? Like, or they're interchangeable. It's like, and I think the core piece really there is like to unlock almost like like an economic model, right? Like similar to how like in non-obvious ways, right? Like a Bitcoin or Ethereum, like, right, it's like unlocked huge demand for that, like basically persistent demand for compute, right? Like, and I think that's actually the other factor, which I think is like extremely underappreciated, is that really like the power even like early on of like proof of work networks was that obviously they have constant demand, right? It's not like they have spiky demand in one moment and then they have no demand on the next day. You can always, like, instead of having your machine go idle, you can always like put it onto the protocol or network, right? And I think that's really the power also here, like of decentralized AI, is that ultimately, like really what we want to produce is like that basically no compute in the world will ever idle. Like basically any idle compute could basically, to make some money, like contribute to a protocol or network like ours. It won't be the highest bidder, if that makes sense, because it will be, for example, like a spot instance, which is preemptible if someone else is willing to pay more and is like taking it. But I think that really gets us back to the point of like commoditizing intelligence, that ultimately we can be the lowest but like consistent like marginal bidder of compute, that always basically puts in the lowest bid, but then like if no one else is bidding, we'll get the low bid of compute. And ultimately I think that really enables us to like get the computer at a much cheaper price at one point, enabled by like distributed training. But I think on the other side, really through protocols and networks, like get to a different scale of like and then novel like economic model basically.
Yeah. I'm curious like how this compares to something like a cache network, because it's really different, right? Like you have a lot more AI specific tooling, and a cache, they don't really do like orchestration the way you're talking about. They just like a provider comes and like registers in the marketplace. Then I come and I like deploy my Kubernetes thing on there and do whatever I'm going to do to host whatever it is I'm hosting. And I can do that across multiple providers if I want, but that's not really what you're talking about. You're talking about like on demand. I kind of like want to understand more about like the orchestration layer, the technology underneath the hood that's making that possible. And then the way the economics work for that.
Totally. Yeah. I think there's 2 or 3 different like layers to it. Like I think on the one side, like we do offer also peer-to-peer compute. Like that's still basically like we've integrated like also with protocols and with like data centers, like from Akash to Lambda Labs. It's like we've basically plugged into all the different compute one can find. And so like ultimately that's still like basically in our system you can still register like GPU, right? Like and rent a GPU, and that's actually at the heart of like what we're currently offering, what like a lot of our users are doing. But then I think the power really and almost like the mindset is the shift is like in those like marketplaces there's idle time, right? It's like they're not like 100% utilized. And in our system, basically the protocol takes the idle compute and utilizes it. So if like you put on like Nature 100, right? Like and it isn't rented out to someone else, it will contribute to the protocol, which is basically, for example, distributed training runs going. So basically we can become like the most efficient peer-to-peer like compute intelligence.
Who's doing the training runs in that example?
Yes, so basically like we have 2 or 3 different models. Like right now, right, it's like we're starting to scale those training runs. So we are basically initiating the first training run. But in the future, the plan is that like anyone could start a training run and then basically take up like the cheapest compute on the network, like when it's idle, and then basically do a training run much cheaper. But really, like what we're interested in, right, is like can the protocol and the network like collectively create basically open and decentralized superintelligence, right? And in the most efficient way possible, which doesn't necessarily mean always starting from scratch on a pre-training, spending like 100 million to get to like DeepSeek performance, but rather being like, what can we do on top of say Quen or DeepSeek or Llama to make those models like much, much better, much, much more intelligent on coding, on math, on other like economically valuable tasks.
I love it. I mean, this is like, I'm so happy we've talked, because that question is like, can we make open source super intelligence on crypto rails has been a big burning question for me. And I think it's a super ambitious project and question to try to answer as a team. But if you do it, I mean, it's like $1 trillion opportunity. It's huge. It's hard to quantify how big it is. And I wonder if this is going to be like the L1 race from, the last 10 years, where these networks that are going after open intelligence are going to be the next, you're going to, you guys are one of the first, right? Maybe you're like the Ethereum of ASI. And then there's going to be there's going to be a Solana. There'll be a bunch of different takes on that, of ways to do it. And you'll have multiple ASIs, open intelligence networks. That could be the future. But it's going to take somebody to get there first and prove it can be done in a reasonable time frame, right?
Yeah.
What's your time frame? If you had to put make a bet, how fast can we get there?
Yes, I think, you're spot on. I think really the end state, right? I think it's almost we are, I think, on this trajectory, right? With different almost unlocks of I think in this discussion, right? With AGI, it's we're already past the chatbot stage, right? It's with AIs broadly, right? Onto the reasoning stage, and now moving on to the agent stage, right? Which I think is starts to become extremely relevant. And I think really actually, I think interestingly overlapping with some of the early crypto ideas, I think one really powerful idea is fully autonomous agents, but also fully autonomous organizations composed of fully autonomous agents, right? So almost in this original idea of the DAO, I think they're basically coming full circle, where I think that the first iteration of it, right, was kind of bottlenecked by the humans in the loop, right, and by coordination challenges. But I think really, I think where we can get to a place, right, where ultimately protocols and peer-to-peer networks can self-improve, right? It's the main contributor to our protocol, I hope, will be AGI at some point, right? And or ASI at some point, and it ultimately self-maintains and improves, right? It's
once you hit that space, it will explode. It will explode.
It's if you basically can't improve your protocol autonomously, you won't be able to keep up with the protocol that does, right? So I think it's actually a really key thing we're thinking about. It's how to design the protocol in a way where it can self-upgrade and improve in a safe way, right? It's it needs to be 100% robust, right? It can't break. So I think that's the other challenge, right? It's I think right now we're not there yet, right? It's to self-improve the large protocols and networks of the world, right? Autonomously, but I think we'll get there. And so I think that's actually a key piece. But I think to your question, I think concretely there's almost 2 or 3 different milestones that I see, and I think they're within sight. I think one is really enabling basically this large-scale compute formation, which can power all of this, right? Which can power large-scale post-training runs and pre-training runs, and can power basically frontier models. So that's a big goal for us this year. It's including with Intellect 2 that we just launched. It's can we move up to the frontier model performance, right? It's can we get close to the best models in the world at a fraction of the cost, because we're building more intelligently on top of the leading open models, right? It's to improve them much further. I think that's one milestone. I think the other really, which I think also the AGI labs are chasing, right? It's really almost a drop-in remote worker, right? For anything. And that could be for programming, could be for marketing, could be for anything, right? It's could you get to a point where the model can do long horizon, reliable, basically agentic tasks, right? You give it an instruction and it is doing every step for you.
Yeah, I could run my whole content marketing strategy for the show. I just do this and show up, and it
exactly
does all my tweets, does all the editing, produces basically everything,
Yes, and I think we'll get there. And I think the question is for us is basically what's our unique angle to that is also different from the Web 2 traditional AI startups. And I think there's a power which obviously we've seen, I think, with protocols and networks before, is that they almost they enable fundamentally unique and different applications, right? It's not they're necessarily one-on-one competing with their centralized counterparts, right? It's not L1s and L2s and stablecoins are directly competing with Stripe, they're complementary, right? It's they're adopting each other or whatever. And I think that's really how I think about it. It's can we get to a point where basically it's like extremely powerful agents can autonomously operate on our network and create value, right? And I think that's like, I think the focus basically for the foreseeable future is like basically getting to the point where we can create like extremely powerful agents. And obviously we've seen like a very kind of like early stage, like that is still easy to basically like put into the toy bucket of like early on-chain like agents. But I think we're quickly moving with like the capabilities to like enable much more powerful agents, right? Like which could enable much more powerful use cases. But I think it's basically, it's like it will take some time, right? But I think like ultimately with AI progress in the back, I think we will be able to like speed up our development like over the next few years, right? It's like, I think every software developer next year or the year after will be much more productive than this year, right? So I think, and then at some point, maybe not even needed anymore. So I think really we're like, yeah, on a like the question I think is like basically, which I think is the biggest question, right? Like on the mind of everyone in AI is like, will we get actually this exponential? Like you probably read like some of those pieces. Like there was a recent one called AI 27 and situational awareness by Leopold, and it's like, will we get to this exponential of like basically self-improving like AIs, right? Like the AI scientists and basically superhuman coding that can get us there, or like what are basically the bottlenecks in this paradigm? And I think the answer comes back to it will be constrained by compute and capital, right? Like it's like even in OpenAI or Google doesn't have infinite capital, right? Like and like they can only run so many automated experiments, right? And they only have so much compute, right? Like you can't produce the amount of chips that the world is currently demanding, right? So it's like supply bottlenecked. So it's like supply chains, like capital, like all of these things do put some like constraints of like how exponential we can go, right? Like, but then obviously I think there's also real questions around like, will we asymptote before ASI, you know? It's like, and will it take maybe 10, 20 years instead of like 5 to 10, you know?
Yeah.
But I think like it's very plausible that like we'll get pretty like crazy progress in the next 50 years. And I think like that's what we're basically, we are basically just like preparing for the scenario where we get like the exponential progress with like AGI this year, next year, and like ASI in the next like 5 years or something, which I think is obviously on the optimistic side, but I think it's really like you can't be too you can't be too prepared or something, you know? It's like everyone can't be optimistic enough to put all the foundations in place, like to steer us well into that future. And I think that's really like the goal is like, can we figure out in time like an alternative system, right? Like that aligns better with humans, that is more democratic, more freedom preserving, and that ultimately can actually take over like some of the centralized like providers and efforts.
Yeah, I couldn't agree more. So one last, I've got two more questions, but the first one is, are you building this on your own blockchain or are you going to build this on like another L1, like the token anyway?
Yes, so we're still honestly early in this process. Like initially we started out the protocol as a EVM kind of like compatible like piece. So we've like started this on the Sequoia testnet, but I think really like I think in the long term, like I think one will probably need one's own like chain more in a sense to get to actually this like self-improvement loop, right? It's like you don't want to be limited by the underlying chain. And I think it's like even the most optimistic like chains I think aren't ready for the like TPS or for like the demand that like super intelligence would have, right? Like they can just like parallelize like a trillion agents, right? It's like they'll like run at a different frequency than humans, right? And I think so. I think in the midterm, like we will probably have to build our own just to like build the technical foundations that can actually align with that scale. But I think it's still something we're like exploring like the best way to obviously be interoperable with everything. So I think that's the other piece. Like obviously we do believe in like the kind of like the foundations that have been put in place by like the Ethereums and the Solanas of the world, and want to be interoperable with them, right? It's like, but I think we don't want to be bottlenecked by them, if that makes sense. Like basically we want to like we won't want to be sovereign, but like we want to trade and integrate with those like ecosystems, right?
Yeah, there's some really interesting like architectures on Solana too for creating like extensions to the network that kind of give you the sovereignty you're talking about. that are worth exploring, and I can try to help point you in the right direction. Well, thanks so much for coming on the show. It's been a pleasure having you on. I'd love to have you on again in like 6 months or something so we can check in and see where you're at. Appreciate it.